Hello. Thanks for the opportunity to share the progress of the theory working group and where we're headed next. I'm Amanda Gallinat. I'm a postdoctoral researcher with the University of Wisconsin-Milwaukee and the National Phenology Network. And I co-chair the theory working group alongside Abby Lewis, who is a PhD candidate at Virginia Tech. So every month our group gathers remotely from around the world to explore how ecological forecasting can energize and advance ecological theory, and in turn, how ecological theory can serve as a foundation for ecological forecasts. If you're interested in joining us, please do. We meet again in June, on June 7th. So in the past year, the theory working group's efforts have been focused on the preparation of a manuscript led by Abby Lewis, entitled "The Power of Forecasts to Advance Ecological Theory." And in the paper, we propose a conceptual framework for enhancing fundamental ecological theory through the development, comparison, and synthesis of forecasts. And we argue that forecasting presents a really unique opportunity to rapidly advance theory by centering prediction. So today, I'd like to share a couple ideas from that manuscript and let you know what some of the next steps might be for the theory working group. As many of you are well aware, forecasting enables and even requires researchers to hone broader theory into specific quantitative hypotheses about ecological processes. We represent those processes in models and then generate specific quantitative predictions based on our hypotheses. By testing those predictions with new data, we can evaluate and refine our hypotheses. And this process can be iterated in a forecast cycle as new data are collected, which allows us to conduct repeated tests of our ecological hypotheses. And compared to retrospective analyses where existing data might support multiple competing models equally, iterative forecasting allows us to predict forward to the times and places where competing models diverge. And then we can target sampling to refute at least one of our competing models or hypotheses. So in addition to exploring how predictability in forecasts can advance ecological theory, our working group is also focused a lot on the value of transferability, or how well a model performs when it's applied outside of the system in which it was developed. And that could include a new time, location, or species, among other transfers. And transferability can tell us a lot about the generality of ecological structure and function, and also help us to identify ecological novelty. And all of those are key to identifying the overarching rules and patterns in ecology. So as we look toward the future of forecasting, advancing ecological theory, our group has highlighted two hypotheses about the relationships that govern ecological predictability. The first is that predictability decreases with increasing forecast horizon, and that the rate of decrease varies across ecological variables, scales, and with the dominant sources of uncertainty in the forecast. Our second hypothesis is that predictability increases with biological and ecological aggregation, for instance, at broad compared to finer spatial grains. And as we explore our next steps as a group, which is just happening now, there's a lot of interest in testing these hypotheses. And we've discussed testing them using the wealth of forecasts produced by participants in the EFI-RCN's Neon Ecological Forecasting Challenge, as well as the forecasts produced by you all, the broader EFI community. So if any of this has piqued your interest, I really encourage you to join us. The next meeting, again, is on June 7th, and you can also find us on the Theory channel of the EFI Slack. Thanks so much.